What's up, mobile devs? Today we are going to unleash the power of the Interpolate function from Reanimated package. And to do it, we are going to build this amazing animation. So right here we can see that we are animating basically the border radius of the square in order to convert the square to a circle. We are animating the scale of our circle. And we are animating the translate Y and the opacity value of our text. So what's interesting is that everything depends on just a single shared value, that is our translateX value, so the amount that we are scrolling on the horizontal axis. So if you like this content, remember to subscribe to this channel. And remember also that all the source code is fully available on GitHub. So let's start. Here I have created a React Native project with Expo CLI. I specified the TypeScript configuration right here. And I've already installed the React Native Reanimated package. We need at least version 2.0. And in the end, I've added in the bubble config.js the React Native Reanimated plugin to enable the work like keyword. So let's start to define our scroll view. We will use right now an animated scroll view. We will understand later why actually we need an animated scroll view with animated imported from React Native Reanimated and not a React Native scroll view. So let's start also to define our words. Here we will have the title of each page. Each title will be displayed in the middle of the screen. So here I'm writing "What's up, mobile devs." Of course, you can use whatever kind of words you want. And let's specify right here our style. So I will write styles.container. Let's define a background color red just to see if everything is set up fine. So let's map our words. Here I'm just returning a view. So here React Native is complaining about the fact that each child in a list should have a unique key property. So let's specify the key. I will use index from the map. So everything is fine. Since we have to do a lot of work with a single page, every single page, I think it's a better option to define another component to handle the page. So let's specify our components folder. And let's write right here page.tsx. I will import React from React, import view from React Native. So let's define our page props. We need actually a title and an index. So let's say a title is of type string, index of type number. And let's define our component page. Page will be a React functional component with those properties. And we can return a React Native view. So let's export our page. We can already access our page right here. We need to specify the page props, so title from here and index, and we are good to go. So we need to understand how to display our page. So the page will fill completely the screen. So we need to handle the screen height and width. And we can do it with the dimensions API from React Native. So let's say height and width. And let's specify our style. So height and width. At the end, I will just use, let's say, a blue background color. So by default, the scroll view has a vertical behavior, so a vertical scroll. We need to deal with an horizontal scroll view. So let's specify horizontal in our animated scroll view. we need actually to save the file, and everything is working fine. Let's refactor a little bit this code using stylesheet. So I will import stylesheet from React Native. Let's define the styles equal to stylesheet.create, and let's write here page container width, height, and background color. Actually, we don't need a background color. And let's add our style, so styles.pageContainer. So to enhance the scrolling experience, usually I like to play with the same color, but playing just with the color opacity. So let's define a blue with the RGBA notation. And let's play a little bit with the opacity value. So what I like to do basically is to change the opacity depending on the current page index. So I'm taking the index from the properties right here, and let's say 0.index. So for the first page, we will have a 0 opacity. For the second page, a 0.1 opacity, 0.2 for the third page, and so on and so forth. So here basically we have a blue with a 0 opacity. Usually to avoid this kind of behavior, I like to sum +2 offset, and everything is working fine. So for the first page, we will have a 0.2 opacity, so a blue with a 0.2 opacity. For the second page, a 0.3, and so on and so forth. So we need to display actually a square in the middle of the screen. So this square, we will play after a little bit with this square. We will play with the border radius and with the scale value. We will actually animate the border radius in order to convert the square to a circle. So to deal with that, of course, we need to specify our square as an animated view with animated imported by React Native Reanimated. So let's specify styles.square. We need to specify the width and the height. Let's specify right here the square size. So I will use basically the screen width multiplied by 0.7. So the square will cover the 70% of the screen width. Here we can write height equals to size and width equals to size. Let's add our background color. I will use RGBA notation. We will use a blue with a 0.4 opacity. Yeah, I think it's fine. We need actually to center this square in the middle of the screen. So let's say align items equal to center, and justify content equals to center. So what is missing right now for this animation? Of course, we want to interpolate, but we want to interpolate the translateX value. So we need to find a way to access actually the amount that we are scrolling on the horizontal axis. So to deal with that, let's start to define in the app component our scroll handler. So the scroll handler will be basically returned by our useAnimatedScrollHandler hook from React Native Reanimated. With this hook, we can access the scroll event, and with the event.contentOffset.x, we can access the horizontal amount that we are scrolling. So to see something, we need to assign on the onScroll property of the scroll view the scroll handler. At the beginning of the tutorial, I told you that we need an animated scroll view instead of a scroll view from React Native. The reason behind that is that we actually need to assign an animated scroll handler to the onScroll property. And we can do that because right here we have an animated scroll view. So that's why actually we need to deal with an animated scroll view. So let's see what's going on. So basically when we drag, what happens? Here we can visualize actually the event.contentOffset.x, but we can see that React Native is complaining about the fact that we haven't specified the scroll event throttle. So let's specify it. Let's say scroll event throttle equals to 16. Actually, why we need to use 16 for the scroll event? Why we need to assign 16 to the scroll event throttle property? So let's understand what we want to achieve. We want to achieve basically a 60 FPS animation. 60 FPS means 60 frames per second. So we need to fire and to handle basically a frame each 16 milliseconds. So it's just 1 divided by 60, and we get 16 milliseconds. So with the scroll event throttle, we are basically specifying that we want to fire the onScroll method each 16 milliseconds. Let's see what's going on. And we can finally see our translateX value. So for the first page, we will have a translateX value equals to 0. For the second page, translateX value will be equal to width, more or less. So here is equal to width, the width of the screen. For the third page, it will be equal to 2 multiplied by width, by the screen width. So actually the event content offset X value is pretty useful. But we want actually to store this value in a shared value. So let's create our translateX shared value, and let's assign the translateX value, the event.contentOffset.x, to our translateX value. So right now everything will be stored in our translateX, and we can start to interpolate and to animate with our translateX. Since all the animation will be handled on the page component, actually we need to pass this translateX value to our page component. So let's write translateX equals to translateX. Of course, TypeScript is complaining about the fact that we need actually to add the translateX value to the page properties. So let's write translateX is an animated shared value of type number, and we can access our translateX property here. So we want to animate. Let's start to animate the scale of our square. So to animate the scale, of course, we need an animated style. I'm writing just a reanimated style with R style notation. Let's specify let's use the useAnimatedStyle hook from React Native Reanimated, and let's return transform with scale set to 1. So it's basically the default value of the scale, R style. So we want basically to understand how to define our scale depending on translateX value. So we define scale, and we will use actually the Interpolate method from React Native Reanimated. So Interpolate needs a number, an input range, an output range, and an optional value that is basically the type. Let's start to specify the value. We want to interpolate our translateX value. Here we need the input range, here the output range. So I will write here the input range. So index -1 multiplied by width, index multiplied by width, and index +1 multiplied by width. And here we can basically write the output range. So let's understand a little bit what I've done right here. So basically what we are saying to the scale style. We are basically saying that when translateX value is equal to index minus 1 multiplied by width, our scale value should be equal to 0. Otherwise, when the translateX value is equal to index multiplied by width, our scale value should be equal to 1. And when translateX value is equal to index plus 1 multiplied by width, our scale value should be equal to 0. So just for the sake of clarity, when the translateX value is a value between index multiplied by width and index plus 1 multiplied by width, our scale value will be a value between 1 and 0. Let's try to understand with an example what should happen on the first page. So we already know that here in this position the translateX is basically equal to 0, and it will be therefore equals to index multiplied by width, since for the first page index is equal to 0. So when translateX value is equal to index multiplied by width, the scale value should be equal to 1. When the translateX value, so when we will translate to the next page, the translateX value will go to this value, so index plus 1 multiplied by width. So translateX value is going to be at some point index, so 0 plus 1, 1 multiplied by width. It will be equal to the width value. When this will happen, the scale value will go to value 0. So the square will scale to 0. So let's see if that is true. And we can actually see that everything is fine. So everything is working properly. So for the second page, we can see actually that it is scaling nicely, and that's because the translateX value right here, it will be equal to width, that is basically equal to index multiplied by width, since for the second page index will be equal to 1. Therefore, our scale value will be equal to 0. So what is interesting is that we are defining our input range with the index value. So the input range will be different for each page. So it is interesting also to ask to ourselves, what if translateX value is greater than index plus 1 multiplied by width? Or what if translateX value is less than index minus 1 multiplied by width? So in this case, by default, the scale value will decrease if the translateX value is less than index minus 1 multiplied by width, and it will decrease also if translateX value is greater than index plus 1 multiplied by width. And for example, if our translateX value is equal to index plus 2 multiplied by width, automatically the interpolate function by default will extend the behavior of our input and output range, and our scale value will be equal to -1. So we want to avoid this kind of behavior. We want to clamp the scale value to a fixed value. So if the translateX value is greater than index plus 1 multiplied by width, we want that our scale stays equal to 0. To force this kind of behavior, we can pass to our interpolate function extrapolate.clamp. So let's see. So everything is working as before, but basically before, when we were right here, the first page, the scale of the first square was updating its scale with a negative scale. So right now, instead, we force the behavior to be with scale 0. I hope that this is clear. This isn't an easy concept, but when we understand in a clear way the interpolate function, we can do a lot. A lot of stuff. So let's try to animate also the border radius of the square, just to be clear. Here we can define the interpolate, the border radius with interpolate. So let's pass translateX value, and let's pass the same input range as before with a default output range and extrapolate clamp. So basically what we want to achieve for our border radius. When we are on the first page, so translateX is equal to 0, so we are in that case right here, we want that our border radius is equal to size divided by 2, since we want to convert our square in a circle. Size basically is the square size, just to be clear. And otherwise, we want that the circle, when we when we scroll a little bit from left to right, we want that our circle returns back to be a square. So let's pass the border radius and let's see if everything works fine. So we can see that everything is set up nice. Here we can see our circle. And I think that's all for the square component, the animation on the square. Just to keep the code clean, let's try to define input range, and let's pass the input range here. Perfect. So let's try to define our text. We need to animate, of course, the text, but we need first of all to define the text component. Let's import text from React Native and let's pass the title. We will make actually a lot of animation with our text, and therefore we need to wrap our text with an animated view. To center the text, let's just define as a style position absolute. So everything is set up fine. We need to define our text style. So let's say styles.text. Let's specify right here the text. We want a font size of 670. A background color, a color of white. We want to make everything uppercase, so let's use text transform uppercase. And let's say font weight equals to 700. So it looks great. So we need just to animate. So how to deal with that? Let's define first of all our animated style, reanimated style. So as our text style equals to use animated style, and let's return basically. So first of all, what we want to animate first. I think it's a good idea to animate first the translate Y. With the text value, we want to animate the translate Y property and the opacity property. So let's start from translate Y. Translate Y. I will just keep translate Y equals to 0 right now. Let's pass. So we need to pass the animated style to the animated view, otherwise it will not work. And let's specify here reanimated text style. So since translate Y right now is equal to 0, nothing will change. So we want to animate our translate Y based on the amount that we have scrolled on the horizontal axis. So let's say translate Y equals to, we will use of course interpolate function, translateX input range, and we can play a little bit with our output range. So when we are in this position right here, we know that this is the value to look, and we want that the translate y is equal to 0, because we want the text on the middle of the screen. Otherwise, we want to make an animation from bottom to top. So let's see what's going on if we write 200 and minus 200. So nothing will change because we need to assign translate y. So we can see a nice animation from bottom to top. So instead of 200, we can use the height. Let's say height, screen height divided by 2 and minus screen height divided by 2. So everything is working fine. So we need basically just to animate the opacity. Let's try to animate the opacity, and we will of course use as before the interpolate function. Let's use translateX value, the same input range as before, and let's say let's keep the default value for now. So we want that when we are in this position, the opacity value is equal to 1. Otherwise, we are expecting that the text fades. So to fade the text, we need to pass, instead of 1, 0. And it will complete the fading when we will arrive right here. So let's see. And that's true. We can see that words is fading nicely, but we want to improve the speed of this operation. So to improve the speed, we can use two ways to do it. We can change, for example, the opacity right here. Instead of 0, we can say for instance -2. Let's see. So we can see that everything is fine, because basically -2 will have the same behavior of 0, of opacity 0, but 1 will reach the value 0 much more faster than before. Otherwise, another way to do it is by updating the input range. So we can change the input range in order to animate faster, and we can keep right here the opacity to 0. So what is missing? Of course, I forgot the extrapolate clamp, and we need to specify it right here. So to be honest, extrapolate clamp right here isn't that useful, but is a good practice to keep things in the good place. So we can avoid extrapolate clamp, but when we will go forward to the other page, here we will have a strange behavior, without knowing it, of course, but we will have a strange behavior. So I think we are almost done. The animation looks great right now, but since we want to enable paging and we want to make like the onboarding effect, we need to specify in this, we need to enable the scroll view. So that is of course optional. I like, for example, this animation much more than with the paging, but if we want basically to use this animation to deal with let's say an onboarding, we can use basically paging enabled, and the animation will look great. So I think we are done. So thanks a lot to remaining with me all that time. If you like the video, or if you have a suggestion, leave a comment in the section below. And don't forget to subscribe if you appreciate this content.